Okay, so welcome. We're here to talk about OpenEdge Database Monitoring. You need more than a VST browser. So in this session, we're going to talk about some of the thinking behind creating an OpenEdge monitoring tool and why you cannot simply point a generic tool to the OpenEdge VSTs with some simple SQL queries. We're going to show you how we've incorporated these techniques into ProTop and how you can take advantage of some of the lessons we've learned along the way and hopefully benefit from that. So for those of you who don't know me, my name is Tom Bascom. I've been a Progress user and a roaming DBA since 1987. Yeah, that was a long time ago. I'm a Curmudgeon here at White Star Software, where we provide expert consulting services related to all aspects of Progress and OpenEdge. We have a remote database management service for OpenEdge. If you're interested in that, we'll be happy to talk about it with you. I'm the author of ProTop, a free monitoring tool that you can download from our website. And we specialize in simplifying the job of managing and monitoring the world's best business applications. If you need to reach me for any reason, feel free to send an email to tom@wss.com. So, why do we monitor? Well, the reason that we monitor databases is primarily so that we can identify reliability and robustness issues before they become problems for the business. We focus on reliability first because being fast but wrong is not helpful. Obviously, once you've got the robustness issues out of the way, you want to focus on performance bottlenecks because performance is pretty important to the success of the business as well. Once you're fast and reliable, then you have to kind of engage in some continuous constant vigilance. You want to focus your improvement activities on keeping things in good shape, making things better, but especially focus on what's actually important, the parts of the application that are being used and that contribute to performance problems or reliability and robustness issues are the ones you want to focus on. You don't want to just randomly change things. It's always helpful to have historical data so that you can do long-term trend analysis and see how things have been changing over time as the business has grown or contracted, hopefully grown, or as you've made changes to the environment around the business to see what that impact has been on the database itself. That historical data is gold when something goes wrong. So you may have been running along just fine for years and then all of a sudden things start misbehaving. Looking at the historical data can give you a ton of insight into what changed and why it's causing a problem, which is really helpful because when you have multiple parties involved, you might have a hardware vendor, you might have some system administrators, you might have some storage people. Having data about what has changed and what's really going on goes a long ways to avoid finger pointing and keeping everybody focused and on track. So there are some options for monitoring OpenEdge. Every OpenEdge installation comes with Promon. It's free. It's part of Progress's distribution, but it is kind of arcane to use. There are a lot of tools out there in the cloud. You've got Nagios, Zabbix, and so on and so forth. And you can connect those to your OpenEdge database using virtual system tables and REST calls and techniques like that. But the problem with them is that they don't know anything about Progress. They've never heard of OpenEdge. They don't have any built-in connectors for OpenEdge. There's no simple way to just click on a button that has OpenEdge on it and magically be up and running. There was a nice talk in 2019 at the Barcelona Pug about building some OpenEdge REST API calls for Zabbix, but unfortunately, there's no download available for that presentation. So kind of out of luck there unless Heino, I think his name was, decides to do that talk again. So our premise is that you need a little bit more than just a VST browser. You can't just point some SQL queries at OpenEdge and hope for it to work. Instead, you need something a little bit more little more customized. So we provide a tool called ProTop. ProTop is our tool for monitoring and bringing alerts to you about your OpenEdge database. The top in ProTop is all about bringing the most important information to your information without making you go hunting for it. So we've tried to organize things and bring it to you in the cleanest manner that we possibly can to keep things efficient. Now, to do that, in spite of the title of the talk, ProTop does get a lot of information from VSTs, but there's a lot more to it than just echoing what the VSTs show you. This is a list of some of the VSTs that we use. It's a partial list. The list changes as things are added. Things have even been removed from the VSTs. When Progress moved to OpenEdge 12, a couple of things were taken away. But there are quite a few of them. There's a lot of data here. There are some notable differences between what is a virtual system table and what is a metaschema table. The virtual system tables are a representation of internal data that's held in shared memory. So they're only available when a server is running. If you start a single user session or do a read-only connection to your database, you don't see the VSTs because they're not persistent. There's no on-disk representation of them. They're all in memory. Another way that you can tell that something is a VST is because it has an ID field. So the first field in the table will be an ID, and that is the only indexed field. So if you try to access the VSTs by some criteria other than the ID, that can be really painful, particularly for things that have a lot of entries like the underbar lock VST. You don't want to try to go through that with a where clause that uses something other than the ID. Along with the VSTs, we often spend time joining to the metaschema tables so that you can enrich the data into a more useful, more user-friendly, presentation. Most of the content in the metaschema tables is fairly static. They don't change all that often, particularly when you're up and running. You can make online changes, you can add files, you can add fields, you can do things like that. You can add extents online and so on and so forth, but still it's fairly rare. Most of that data is pretty static. You can check it periodically. You don't have to keep on top of it every 10 seconds or anything like that. And because they're so frequently referenced, it's a good idea to cache them. So you can cache them in temp tables to avoid excessive reads of the metaschema. If you do create a cache like that, it's a really good idea to build that temp table cache with better indexes than the real metaschema, because the real metaschema has what are perhaps politely called terrible indexes. So we're going to go through an example here. I'm going to do an example on storage area space and how you might monitor the space in a storage area. Usually we suggest that customers use variable extents instead of trying to stay on top of expanding storage areas as they need to, because our experience has been that people who start out with good intentions sooner or later forget that they need to stay on top of it. They forget to expand an area before it starts writing into the variable area, and before you know it, you've got a mix of areas that have been properly cared for, and you got some that are just growing into the variable area. And it's much easier to just let the variable areas grow as long as you're a average to mid-sized user. Really, really big databases, then it might make more sense to pre-allocate some space. And some people just like to pre-allocate space. That's just, they're comfortable doing that. They like to do that. So if you're going to do it, you need to have some good information about how full your storage areas are so that you know when it's time to add them to expand the space that's in them. So one of the ways you can do that is by looking at this area status VST. It has a high watermark and it has total blocks for each storage area. Sounds like it would be perfect. So you might write a little query like this. Looks pretty simple. You're just doing for each area status, no lock, displaying the data that's in there. There are two fields, total blocks and high water, which sound like just exactly what we need to get the information that we're after. So let's see what this comes up with, where we come out here. Well, that's not quite as useful as we might have hoped. You get a lot of information, but there's nothing there that clearly stands out and says, hey, this is the storage area that I need to add some space to, which is pretty typical of working with the VSTs. There's a lot of great raw data, but it needs a lot of help to be presentable. So what's missing here? Well, you can't tell from looking at this which storage area has the most urgent issue. You look at it and you say, "Oh, geez, I don't know which one. Could it be one of these guys with only one free block, or the 57s and the 56s? I don't know. It's hard to say." The disk space isn't expressed in user-friendly terms. It's expressed in blocks, but how big is a block? You don't really know. Well, you might remember, but there's nothing in the data that tells you how much space that is in terms of gigabytes or something useful like that. You don't see how much space is used versus how much is free. You don't really see what's allocated on disk. There's no display of the percentage. So you don't really know if something is 10% full or if it's 90% full. There's no indication of whether or not we're currently writing to a variable extent. You see the last extent over there kind of in the middle, but the last extent doesn't tell you if that's a fixed extent or a variable extent. Is it too late? Are you already writing in the variable extent? And you don't see anything here that tells you whether or not you're approaching any size limits. There are limits on the total size of an area, as well as limits on the size of an extent. Those limits vary based on whether you're running workgroup or enterprise, whether you have 32-bit versus 64-bit, and the storage area type, the block size, and the rows per block can come into play too. So those are all things that are missing from this data. And I have a little list here of what's missing, so you can, when you look at this later, you'll be able to see that without having to have taken notes. So to address some of the missing bits, we want to go out and find stuff like what is the block size? So to find the block size, we have to look at underbar area, which is a metaschema table, not a VST. So we pull that together and we calculate the block size in kilobytes, because that's more convenient than 8192 or 4096. Then we do some calculations to figure out what the space used in terms of gigabytes is, as well as what the percentage full is. And you can see the report is a little bit, or quite a bit, more readable now. We have an idea of how big these storage areas are and what their usage percent is. But we very quickly noticed that a lot of these storage areas are either 99.99% full or 100% full. And the reason for that is that once you start writing into the variable extent, you are always going to be 100% full. So there's no way to easily distinguish between I'm writing in the variable extent and I'm at the end of my last fixed extent, which is kind of a problem. So we're still missing some useful data for managing storage areas. We don't know easily what is the most urgent issue. It would be better to have a more useful percentage full, like perhaps how full is the last fixed extent. We don't have a clear picture of how much space is allocated on disk. We know how much space we're using within the storage area, but if the storage area has been pre-allocated, it's using more space than that on disk. We don't know easily. We can guess when we see 100%, but we don't know for sure if we're writing to a variable extent. We don't even know for sure that we have a variable extent. And again, the size limits are not really addressed here. So we can take it to the next level, and there's a whole lot of code that you can write to do that. But in ProTop, we have a screen where we've already done that for you, where we've added a number of fields here. So we removed a lot of clutter from the first VST browse, the one that filled up the screen, and added a number of columns that are kind of useful. So you see the stuff with purple headers here, that's all stuff that we've added, like whether the area has been assigned to the B1 or the B2 buffer pool. how much space is allocated versus how much is variable. To get that, you have to do a loop over the extents. So you have to go over the individual extents and add them up and determine whether they're fixed extents or variable. To do that, you can't get it just from underbar storage area. I'm sorry, underbar area status. The total gigabytes and the high watermark and the free gigabytes we got from the previous screen, so that was already there. But then calculating the percent allocated versus the percent of the last extent, those are new fields that we had to calculate as part of going out and running through the list of extents. You see that we have the percent allocated all in red here because all of these extents, if you were managing fixed extents, would need to be expanded. This particular customer is not running things that way, so the percent last X column is not in red. Then it's convenient to know the block size, which is 8K for this database, so they're all going to be 8s. The rows per block, the cluster size, number of tables, indexes, and lobs per area. And if you look here, you see that we have a number in red under number of indexes. So there's a red 2 there. And if you look over to the left, you see, oh, that's the schema area. So this is telling us that the schema area has user objects in it, and you generally don't want that. You're trying to keep all of your data in dedicated storage areas, not in the schema area. It's a bad idea to have things in your schema area. So there's 2 indexes here that need to be moved somewhere else, which is also what the asterisk is telling us over in the over to the right. And then we see that all of our extents, or all of our areas, do have a variable extent, and that none of them are anywhere near, even though they're quite large, well, reasonably large, none of them are anywhere near the maximum size for this particular combination of characteristics. So this is an enterprise database, 64 bits, modern version of Progress. The maximum area size is much, much larger than double-digit gigabytes. So we don't need to worry about that. So that's an example of how ProTop helps you. If you want to look at the gory details of that code, you can look in lib/vstlib.p and get area and get var area. Have all the code that actually generated all of that. Another very common issue that we run into, and this is another robustness sort of an issue, is poor transaction scope. Now, you can all probably relate to this, that poor transaction scope only ever happens in other people's code. I mean, I don't write code that has poor transaction scope, and I'm sure you guys don't either, but you do seem to run into it every now and again. So basically, if you consistently have transactions that last more than a few seconds, you probably have a problem. There's 3 main categories of poor transaction scoping problems. You have transactions that span over user interface, that is, they run for a long time. So a user is doing things, maybe not doing much, they might have just gone to lunch, but there's a transaction active while they're sitting on that screen. Then there are business transactions that have been inappropriately implemented as a database transaction. So this is what happens when you have some process that maybe it does a big purge or something like that, that somebody decided that it should be done as a single database transaction. It doesn't need to be a database transaction. It's very restartable. But if you do it as a big database transaction, then you're going to need an enormous lock table, the -L, and you run the risk of that lock table running out and the session crashing and having all your work undone, which is not really a whole lot of fun. Or you have these ad hoc data fix routines that people like to run. And if you're not careful, it's really, really easy to launch one of those with poor transaction scope and blow up your BI file, which is especially annoying if it happens at 5 o'clock in the morning on a Sunday when nobody was really expecting to have their BI file blow up on them. This whole topic of transaction scope is really a presentation unto itself. So we're not going to get really into the gory details of the code around that, but rather how we detect it and what we do about it. So if you do have long transactions, the problem with them is that they drive out of control BI growth. So the BI file can become really, really big. And if it grows big, obviously it's using a lot of disk space, and it could crash your database. If you run out of disk space for the BI file, your database is going to crash. And if that happens, it's difficult to recover, because before you can go through crash recovery, you have to allocate additional disk space so crash recovery can recover. So crash recovery needs to be able to recover from crash recovery crashing. So you end up needing to have 2 or 3 times as much disk space as the size of the BI file in order to go through crash recovery. And if you've blown up the BI file to some really big number, that's a lot of disk space. Another problem with long transactions is that you have a very poor user experience when they run one of these and a large amount of data gets rolled back, either because they didn't realize that the user interface had a transaction active, or because you ran out of some resource like the lock table and it crashed. And these problems are generally caused by poor coding practices, other people's coding practices clearly, but poor coding with regards to buffer and transaction scope. So how do you monitor for that? Well, there is a VST called underbar trans, and you can do a quick little query on it. You do a for each trans where transaction state doesn't equal unknown by duration, which is really handy. Duration is the number of seconds since the transaction was started, and you quickly get a list of what your oldest transactions are. Well, that's actually kind of useful, but it's not quite complete. There's still a few things missing from that. Like one of the things you can't see here is how much before image space is being used. We can kind of guess, since this particular example is only 3 seconds old, that there's not much being used, but in more complex situations, it's much less clear. The other thing that you can't tell from this is whether or not the user is actively working, or are they just sitting there twiddling their thumbs, or maybe they've gone home for the day, gone out to lunch, whatever. Is the user blocked? So are they waiting for a resource like a record lock? So a user could be stuck because they can't move forward, even though they're in a transaction, which would be a fairly bad experience for them to have. And the other thing that you can't see here is what code is the user running that's causing the problem. It would be really helpful, if you're trying to debug it, to know where the problem is so that you can get in there and solve it, rather than just say, oh gosh, there's a problem, figure it out, call the user who probably isn't sitting at their desk. So there's a summary for your notes. So in ProTop, we have a couple of screens that help you to monitor bad transaction scope. The ProTop dashboard, which is at the top of the screen when you start up ProTop, has a section circled over here, which will show a long transaction in red immediately. So we see in this example that we have an 18-minute and 41-second old transaction. It's using 17 BI clusters and about a gigabyte of BI space. So that is kind of problematic. That's more than a well-written application should have. And then you can drill into the details with the transaction detail screen, which is very similar to the query on underbar trans that we had a little while ago, except it has some additional data. You see, once again, there are some columns in purple. So we've added the process ID. We've added a bunch of flags so you know what type of a process it is. These are all shared memory 4GL clients with an active transaction. We know what device it's on, and these bits of information are really useful if you need to go out and disconnect that user or do something at the operating system level. And then over on the right, we have a column for the idle time. So we're able to determine how long it has been since that user had any other database activity. And we see on our first user here, user 620, that the transaction duration is 1841, and they've been idle for 1832. So they've just been sitting there and not doing anything in terms of touching the database for that time. We also see they're not waiting for anything, and that the code they're running is line 8019 of AP/SUPP.P, whatever that is. But you can go and you can look at that code and figure out, well, why is there an active transaction here? Is there user interface going on, and how can I fix that? So you see that users 620, 848, and 448 are basically transactions that are spanning UI and have been idle for most of the time that transaction is there. So somebody went into a screen, they did something, they're still on that screen, they haven't left it yet. The transaction scope is including their waiting. User 512 is almost like that, except they have done something more recently. So they did do something at some point, so they may still be doing useful work. User 907 looks a lot like one of those inappropriately large business transactions. So they've had a transaction running for 11 minutes, but they haven't been idle. They're doing some work. We're not quite sure what that work is. And we can see that they're on line 112,000 of SO/order LE2.p. That's going to be a real code review challenge. But I think it sounds to me like a 100,000 line long program probably needs some code review pretty badly. User 932 has been blocked, waiting for a record lock. And they've been waiting for that record lock for 8 minutes and 24 seconds. So there's clearly a record lock contention issue going on here. And we can look at line 1549 and see why the stock out table is being blocked for this user. So that's some great information, and that's brought to you largely by what's called the client statement cache, which is a feature in the database. It's been around since 10.1c, I think, something like that. It was a little buggy at first, but in modern releases, 11.7 and upward, it's a very good feature that gives you some real awesome insight into what users are doing in your systems. We like it a lot. ProTop can also generate alerts. So if you are one of our commercial customers, you would get an alert on this. You get an email or an SMS message letting you know that there is an old transaction. In this case, the threshold is set quite a bit higher. And it gives you the information about what the user is doing, as well as potentially some information from the operating system level so that you can make decisions about whether you want to disconnect that user or find some other resolution to the problem, like giving them a call and saying, hey, back out of that screen, please. So that's it for transactions. Another example that comes up a lot, particularly when you're having performance problems rather than stability or reliability problems, is which users are your very active sessions. So you have very, very active sessions. And the reason that this is important is because performance bottlenecks are usually caused by contention for resources. And the biggest users of resources usually follow a Pareto distribution. In other words, a very small number of users are generally responsible for a very large proportion of the activity on the system. So it often pays off to see if you can figure out who the busiest users are and what it is they're doing. So there's a VST called user IO, which is pretty promising. User IO shows you for every user ID who they are and what they're doing in terms of their block access, whether or not they're doing logical reads and writes within the database, as well as the disk access. So are they reading and writing database blocks, BI blocks, AI blocks, that kind of stuff. So if you do a for each user IO by DB access descending, you'll see the users who are most busy. Oh, and your busy users also tend to be, strangely enough, they're the ones who often complain the most and the loudest. Funny thing about that. So user IO, you get output that looks kind of like this. So we're sorted and we clearly see that user number 3119 has 3.3 billion DB accesses. That's a big number, 3.3 billion. I happen to know that in this case, that user is Pro2 replication. So there's a replication process that is basically copying data to a external SQL database. So maybe that's not such a bad number. It depends a lot on how long the database has been up, because one of the things about the activity VSTs is that the data you're looking at is since the database started. So if this database started 3 months ago, or if it's been running for a year, 3 billion might not be such a big number. If it's only been running for a couple of hours, 3 billion is a huge number. Another thing that's missing is that we don't have names for all the users. Blank user IDs are apparently being permitted in this database, so that's not very helpful. It would be nice to know something about who that user is and what type of connection it is. Is it a local self-service connection? Is it a remote connection? What's going on here? You don't really have an indication here or any kind of way to tell whether or not this IO that we're looking at is efficient. There's a lot of it, but we don't know if it's efficient or if it's poorly indexed or what the score is as far as that goes. And we don't know what tables and indexes are involved in this IO. We just see a kind of a big generic number. Oh, they're doing a lot of IO. And of course, we want to know what code there is being run to generate that activity. So, a little summary for you right there. ProTop removes a bunch of stuff that's basically noise there, and then adds in some additional information. So where we see a blank user ID, we've gone out and we've used either the operating system name or the device name or the host that the connection is coming from. So we provide a little bit more information about those unknown, unnamed blank users. We're providing the process ID. So if you need to go out in the operating system and do something like disconnect them, you know who they are. And again, we have the flags that tell us whether it's a shared memory or a remote connection, whether it's a 4GL connection or SQL connection, whether it's batch, and so on and so forth. And then we're sorted by the block access. So we can see that our busiest user is right at the top here. There's a column for the hit percentage. So this is telling you whether the IO is efficient or not. Most of these are pretty efficient, but we quickly see that we have one who's doing a lot of OS reads for a relatively small number of accesses. So they're reading in stuff that is not in the buffer cache. This is not terribly efficient. We then have some information about how many record locks are in use by this session. There's a high watermark column. This is 11.7, so it's kind of well, it's a new feature in the VSTs, and it works kind of strangely. For 4GL users, you get the number of record locks, but you don't get the high watermark. For SQL users, you get the high watermark, but you don't get the number of records that are currently locked. I believe that's fixed in some of the OpenEdge 12 releases. Then we have the client statement cache information where we show the age of the cache as well as the line number and the program name. Now that's useful because if somebody's been sitting or has a query that's been running for a while, you want to know that. You want to know that it's been that the second user here, WMS admin, is doing 500,000 block accesses per second and has been doing that for 2 minutes now. So line 13 of this program is probably something we'd like to take a look at and see if maybe we can't make it more efficient. Or line 3970 of this other program might be a good one to take a look at as well. I mentioned SQL, so sometimes you're suspicious about SQL users, so you can look at them specifically and you can see what SQL statements they've been running. SQL statements tend to be very long, but you can often get enough information from just taking a quick look at the first part of it to have a pretty good idea of what's going on and ask some questions about that of the user, particularly if you're allowing ad hoc queries. And then you want to know frequently about the table and index activity. This also follows a Pareto distribution. Very frequently, only a couple of tables are going to be the most active tables by a long shot. So you'll notice that 2 or 3 or half a dozen tables are extremely busy, and the rest of them all kind of trail off after that. So you want to know what those tables are, whether or not that activity correlates to the busy users, which it frequently does. So it's very easy to infer that the busy lines in the user code are accessing those particular tables. But sometimes it's all spread out all over the place in terms of the users, and it's still useful to know which tables are very active because there may be things you can do about those tables. And we'll perhaps talk about that in just a moment. So the table stat and index stat VSTs look very promising. You can just do a for each table stat no lock and display some information. Same with the index stats. And that looks a little bit like this. So you get the ID, you get how many reads, updates, creates, deletes, whether or not it's been doing an operating system read. Now that's useful because that tells you that it wasn't in the cache. The partition ID, maybe not so useful, at least not unless you're running table partitioning. But again, the VSTs are just giving us raw data. They don't identify for us what the most urgent issue is. A table number is not really all that helpful. It's much more useful to know the table name. There's no way to tell from this really whether or not that information is terribly efficient, nor how the table information relates to the index activity. So here's what ProTop does with that information. Yes.
Excuse me, but like 2 minutes ago or so, your camera picture got very blurry. Don't know if you care, but just that you know.
Well, I don't know that I care all that much. Nobody's really looking at my face, are they? Okay, so in ProTop, what we've done with the table and index activity is we've added some information. So we tell you what storage area the table has been assigned to, whether or not that table has been assigned to the B1 cache or the B2 cache. We translate the table name and the index name into meaningful metaschema names, and then give you information that we've obtained from DB analysis. So it's really helpful to know whether a table has a long RM chain, for instance, because that impacts the efficiency of adding new records. How many records are in the table? What the percentage fragmentation is, because a highly fragmented record or highly fragmented table with a lot of fragmented records means that you're doing a lot of extra IO operations, which means that you're much less efficient than you could be. What the scatter factor is, so are things spread out all over the disk, causing the operating system to have to seek back and forth to pull things together. We have this statistic we call churn. Churn is the number of times that you could have read the table, read the whole table during the sample period. So if you have a very small table, like this one here with 38 records in it, and you read it a lot, you're turning that over and over and over. And that means that you're wasting a lot of CPU cycles, and you're probably driving a lot of CPU contention and resource contention. And this may be the source of a lot of bottlenecks. So that's a number that you want to pay attention to. On the index side of things, we know how many blocks are in the index, what the utilization of that index is. So is this an opportunity to run an IDX compact to make things more efficient? How many index levels, what the index root block is. If that shows up on your resources that you're having to wait for, remember back on the transaction screen, there was a wait reason. If that index root block is popping up a lot, that means that you've got a lot of contention for that. And whether or not the index is a primary index or a unique index or a word index or what it is. Typically, you're going to see kind of a correspondence between the tables that are active. So here we see SCRM valid Q is the most active table, and the index for that is going to be, there's usually only one index most of the time, not always, but it usually has very similar number of read operations, so that in that sense they're balanced. But you might see cases where you're doing a great deal more reads on the index, or multiple indexes are doing a lot of reads in an unbalanced way. So that's usually because the where clause is inefficient, and there's an opportunity for you to improve the where clause by looking at the code and figuring out what's going on at that level. So when I'm talking about churn, for instance, we had a recent issue with a customer where they had a very, very large churn that was, it was accounting for about just the access to that one table, one very small table, similar to this, was about 40% of the CPU time on the system. And it was holding back their capability to scale. They wanted to basically double their business, and that would put them pretty much at the limit of, well, put them over the limit of what that server could do. So we were looking at that situation. We discovered that because they were churning so hard on that table, and the table was essentially a read-only table, by turning it into a temp table and making it a global, yeah, okay. Pretend you don't hear this if you're, you know, a coding purist, but by turning that table into a global shared temp table, we eliminated 40% of the CPU utilization on the server without having to change the application code, which would have required thousands of changes spread across the entire application. So we're able to very quickly, within a couple of hours of effort, relieve that performance penalty. And then in theory anyway, the coders can make the longer term changes that are needed there, but it might be a while before that actually happens. Okay, so to summarize, if you're going to have useful monitoring, you need to have the ability to identify and prioritize the issues that you're monitoring. You want to remove as much noise as possible from the environment so that people can focus on what's important. And you're going to need to add context and enrichment to the raw data that you have available to you. As you're using the VSTs, you'll find that there's a lot of context that you need to add that is outside of the raw VSTs. You can't just take the VSTs and spit them out. You need to join in data from metaschema tables. You probably would like to take data from ProUtil DB analysis, ProUtil describe, places like that. In a lot of cases, you're going to derive useful metrics from the raw data. So you're not just going to use the raw data, but you're going to calculate a percentage, or you're going to look at the rate at which things are happening, because the sample interval is also context. You know, it's a lot more useful to know what's happening right now than it is to know what the total amount of activity is over 6 months or a year or whatever. Although it's also useful to know what those long-term things are. Usually you're much more focused on the here and now, or the what's about to happen side of things. So ProTop has already done the work for you, so why reinvent the wheel? Go out and download ProTop, check it out, have some fun with it. It doesn't cost you anything. You can look at quite a bit of the code if you are curious about how things work. We provide that for people if they're interested in that kind of thing. And with that, I can take questions.